Okay, so we are going to look at gravity problem A, and that reads, in Mostar, Bosnia, the ultimate test of a young man's courage once was to jump or step off a 400-year-old bridge into the river below, the River Neretva, which is 23 meters below the bridge. Two questions. How long did the jump last? And how fast was the traveler traveling at impact? Okay, so we have to identify the object, and that is the boy, because after all, it's not until after he hits the water that he becomes a young man. The initial condition and the final condition. When do we start caring about the motion? When do we stop caring about the motion? So when he steps off the bridge is when we start to care, and when he hits the water is when we stop caring. We want to sort of reflect now at this point, are we in a state of free fall? Yes. So we want to remember as we move into our problem solving that this is a free fall problem. Once he steps off that bridge, the only influence on him is gravity. Okay, so like with everything else, we're going to identify our world. So here's the bridge, here's the water below, and we can identify the origin. I'm going to put the origin at the location of the bridge. Okay, next step, making our list of knowns. So x initial, x final, v initial, v final, acceleration, and time. And feel free always to pause the video and do your list and then check to see if you did it right. All right, x initial is where he steps off the bridge. I've defined that as 0. X final is when he hits the water. And we are told in the problem that the bridge is 23 meters high. So we know x final is going to be at 23 meters. But is it positive or negative? Well, it's below the origin. So we're at negative 23 meters. When he steps off, he has an initial velocity of 0 meters per second, so he is stepping off of the block, and we don't know how fast he is going when he hits the water. Because we're in a state of free fall, we know the acceleration is gravity, so we have negative 9.8 meters per second squared, and we don't know how long it takes. All right, so our first question is a matter of how long. That's going to give us our time variable. So both equations, remember we have two. One is related to position, and the other is related to velocity. We'll both have time in them, so which one's going to help us get at that time? Well, that's when we look to see which one has more variables we know. Turns out it's that position equation. So x final equals x initial plus v initial t plus 1/2 a t squared. So our x final is negative 23, x initial is 0, plus 0 times our time plus 1/2 negative 9.8 times our time squared. Both those go away. 0 times anything is 0. We have negative 23 equals minus 4.9, 1/2 of 9.8, times time squared, and we find that our time is equal to 2.17 seconds. So it takes 2 seconds to fall off that bridge. All right, so that can now go in our list and is part A. The second half of the question asks, how fast is he going when he hits the ground? Well, now we can look at our V final. So we're interested in how fast is he going when he hits the bridge. V final, or the water, is equal to V initial plus acceleration times time. V final is what we want to know. That's a variable is unknown. V initial is 0. He is stepping off the bridge plus negative 9.8 times our time t. So V final is equal to negative 9.8 times our calculated time of 2.17. And V final is negative 21.3 meters per second squared. Pretty fast. All right, let's evaluate that. Does it make sense? Well, it's negative. Should it be negative? Yeah, he's moving in the downward direction. That negative tells us he's moving downward. So, same process as all our one-dimensional motion, with this key factor recognizing that we're in a state of free fall, and therefore we have an implied value of negative 9.8. Good job.